Hi everyone, and welcome to this new class on this course of Aerospace Engineering, Aircraft Systems and Avionics. In this class we will discuss flight instruments, tackling specifically the basic components. So, as many of you know, it is important for engineers to design a set of instruments which are intuitive and easy to understand and operate by pilots, reducing any foreseeable risk related to human error is essential. The flight instruments located in the cockpit of the aircraft are the means by which the pilot is able to identify the orientation and velocity of the aircraft. Flight instruments inform us of the conditions of the flight so that we, as pilots, can operate accordingly depending on our destination and route to take. Many additional instruments are used also to communicate with traffic control, for instance, or either to determine the location of the destination airport. Here I've put 3 examples of flight instruments in a Cessna 172, an Airbus A320 and an F-16 Fighting Falcon. Right, so the first aircraft is a civil, relatively small aircraft with distinguishable instruments, okay? We can quickly identify the attitude indicator, for instance, the airspeed indicator over here, the altimeter, and more, okay? Right, so in the commercial Airbus A320, similar to the Boeing 737 for instance, the instruments might not appear as clear as in the case of the Cessna. Yet we can quickly identify the attitude indicator, for instance, and many other instruments which were completely important in order to determine the position, orientation of the aircraft. Right, so in the case of the F-16 Fighting Falcon, we also identify the attitude indicator over here and many more, okay? Also the airspeed indicator and the altimeter, for instance. Right, so let's go to the point. The basic components that we will study in this course are the following: airspeed indicator, this one over here, the attitude indicator, then we have the altimeter, the turn indicator, the heading indicator, and the vertical speed indicator. Right, so the thing is, in aviation, clarity is always an asset. Note that this configuration, named the T arrangement, is common in many aircraft, especially and specifically in civil aircraft. This is done so that the pilot can quickly identify all of the variables at a glance, without doubting what they represent. The engineering of all of these components can be divided into 2 types: gyroscopic instruments and pressure-based instruments, the latter being called also pitot static instruments. Right, so the airspeed indicator, the altimeter, and the vertical speed indicator will operate based on the changes in the pressure of the surrounding air. However, the attitude indicator, the turn indicator, and heading indicator will operate on gyroscopes. So in next class what we will do is study in detail how all of these instruments work.